Alright, so we're going to do regressions, and we're going to do them a couple of different ways. So the first thing I want to do is just an analytical regression. Let me move this guy over here so it makes it a little bit easier to do the click and pick. So what we're going to do is come over here to data, and you should have your data analysis added. If you don't, again, you go into File, Options, Add-ins, and then click on the Excel add-ins and make sure all these guys are checked. If you have any problem with that on one of the university computers, you can just go to the help desk and they'll update it for you. Excuse me, I need to take a drink of water. Alright, as I said, we're going to go with a data analysis. And what we want to do is run a regression. So our Y's are the monthly returns for our stock. So I'm going to come over here to stock 1M for monthly, and then we'll go ahead and select them. Control Shift down arrow. Then we want, oh, you know what? Actually, I'm going to change this name real quick. Let me exit that. So this is going to be the Abbott ABT returns, not ABB, ABT. And this one is going to be, I got it wrong. This one's going to be my SPY return, SPY. And this one is going to be my Abbott, ABT. Alright, now, set up a little bit better. We're going to go back to our data. We're going to run our data analysis. We're going to run our regression. Check here for labels in first row. So our input range is now going to be Abbott returns. That's the Y. Our X variable is going to be our SPY returns. We want residuals and standardized residuals, and we're going to output to a new worksheet that's going to be called MKT-Reg. And then go ahead and click OK. So we created a new worksheet called Market Reg. That's where the output's being dropped. We'll get things organized here a little bit by just double clicking to be able to see everything. So these are our results. The R squared represents how well your model fits the data that's out there. So we're explaining 58% of the variance of the data. Our adjusted R squared means that we're reducing, because we have the more variables you have, naturally the more explanatory power you have. We adjust the R squared in order to account for the number of variables you're using to do the explanation. We want model fits up here that are at least 30%. If you get down below 30%, the quality of the model is questionable. And you know, for bigger stocks and the data, the stock selections on larger stocks, I've limited the amount of we've filtered the stocks so that you're getting bigger stocks. So most of your fits should be fairly decent. Probably the most important number up here is what's referred to as the standard error of the estimate. So this is a conditional expectation. So given the return of the market, the return of Abbott is going to be the return of the market times the slope, which is my SPY return function here, plus the intercept that's going to go on. And then we want to see if they're statistically significant, and they're not. So p-values here should be 0.1 or below, preferably 0.05 or below to be significant. So the intercept isn't significant. On the other hand, the coefficient is highly significant with a t-stat of 9 and a p-value of basically 0. So we got a lot of significance here. So the standard error, the estimate, is basically just the standard deviation of the residuals. So I'm just going to actually show that to you. This is going to be equal to standard dev of sample, and I'm going to pick the residuals. And then go ahead and hit return. So this represents the standard deviation of the residuals. It's a little bit different because of the degrees of freedom in the regression. We have to subtract a degree of freedom for each one of the estimates that are occurring, and there's 2 estimates. One is the intercept, one is the coefficient. This is also referred to as the beta of the stock. Well, you can see these 2 numbers are pretty accurate. I'm going to go ahead and drag this equation over. So this is the standard deviation of the standardized residuals. You can take any distribution and convert it into a normal distribution by subtracting the mean and dividing by the standard deviation. That creates a distribution with a mean of 0 and a standard deviation of exactly 1. And that's what we mean by the standardized residuals that are coming in there. And those standardized residuals are used to try and estimate if the error is normal. Don't want to get too much into the statistics of it. So if we were going to apply this equation, what we would say is that the return on Abbott is going to be equal to the intercept plus the coefficient multiplied by, I'm just going to pick a cell over here, the market return. So if I said the market return was 10%, the return on Abbott should be 14. This beta represents the systematic risk of Abbott. So it's how much is it exposed to the market. And here it's more risky than the overall market. The return on the market, or the beta of the market, the coefficient of the market, is always 1. So anytime you have a beta or this coefficient is greater than 1, you have more risk associated with the stock, also more expected return. And anytime this is less than 1, then you have less systematic risk and therefore less expected return. Alright, so the great thing about the model function when we go through data analysis is we get a lot of different numbers out that allow us to gauge the accuracy of the model and how functional the model is. The problem with this is that if I'm going to go into my data and I'm going to make a big change here. So instead of 0.08, I'm just going to change this number to 0.8. So that should make the regression significantly different. My scatter plot is now updated. You notice that you have this point way up here. My return plot is now updated, and we have this point that's way up here. But my regression data hasn't changed at all. So when you use this data analysis tool, the great thing is you get good analytics off of it. The bad thing about it is the fact that it doesn't update automatically with your analysis. And when we're designing spreadsheets, we want spreadsheets that update automatically when the data changes. So I'm going to go ahead and just undo. That takes my number back to where it's supposed to be. I'm going to go ahead and save my file. And the last thing I'm going to do is come to the return plot. Now it's updated again. One of the things you can see, Abbott is in orange, at least it's on my screen it's orange, on your screen it may be a little bit different. And SPY is in blue, and you can see that they both move kind of together. In other words, they're correlated. The correlation is fairly strong through here, and it starts to break down a little bit as we get towards the end of 2017. When you see a plot like this where the two things are pretty correlated, it tells you that a conditional model is probably a better way to go than an unconditional expectation, meaning just using the average. So when we come back on the next video, we're going to go and create an estimate of the return on SPY, and we're going to do our conditional expectations using intercept, slope, R-squared, and SEE functions. All right, thank you very much, and we'll come back, we'll do these, finish this tab pretty quickly. Thanks. Bye.